Why care about another roaming rock in space when there are literally trillions of restless rocky bodies ready to rumble with the Earth? Well, that's because this is a rare rock racing right through our neighborhood from another solar system. Comet 3i Atlas is only the third interstellar object ever discovered, and it's going to be at its closest point to Earth on December 19th, and I think we should be ready to take photos of it. In this video, I'll tell you a little bit about Comet 3i Atlas, what it is, where it's coming from, how we know it is interstellar, and how to observe it, how to image it, as well as I'll talk a little bit about the theories that have come out about Comet 3i Atlas over the last few months. Back in August, I made a video about how to find and track Comet 3i Atlas in Stellarium from anywhere on the planet. And at that point, the discovery was still pretty new. It was only about a month old. But now we're into November and getting into December, and we know a lot more about this comet. The comet reached perihelion, or its closest point to the sun, on October 30th, where it was behind the sun's glow, so it was much harder to observe. But now it's on the other side, and we can start seeing it from Earth. And yes, we can use amateur gear to be able to observe and image it, and I'll talk a little bit about that in this video. Let's quickly go over some of the facts about this comet. Comet 3i Atlas was discovered on July 1st by the Atlas Survey in Chile. Atlas is short for the Asteroid Terrestrial Impact Last Alert System, and we've talked about Atlas in this channel quite a bit, and they're responsible for finding tens of thousands of comets and asteroids since the program went live. And we were able to find pre-cover images of this comet going back to June 14th, 2025. So what is Comet 3i Atlas? Well, as the name suggests, it is a comet, complete with a nucleus and a tail. Observations confirm that it contains volatile ices like water and CO2 that vaporized as it gets heated by the sun. Now, it's always pretty difficult to estimate the size of a comet. The current estimates of this comet is between 440 meters and about 5.6 kilometers, but a best guess is probably somewhere in the middle, around 3 kilometers in size. After short observations, we were able to determine that this has a hyperbolic trajectory, which means it's not gravitationally bound by the sun, and translation is that it's not from around here and it's not sticking around. And we know this because of its speed. When it was discovered, the speed was about 221,000 kilometers an hour, or about 137,000 miles an hour, which is wickedly fast. And if you compare it to something that humans have launched, Voyager 1, which is currently the fastest spacecraft leaving the solar system, it's only going at about 61,000 kilometers an hour. So it's dwarfed by the 210,000 kilometers per hour that 3i Atlas is traveling. Now, where is this comet coming from? The comet seems to be approaching us from the constellation Sagittarius, right near the Milky Way's core. It entered almost edge on to the ecliptic, only about 5 degrees off. And one of the reasons we were able to discover it with Atlas is because the Atlas survey primarily monitors the ecliptic, because that's where most of the rocky bodies in space are, from the asteroid belt to the Kuiper belt. So if Comet 3i Atlas did enter at maybe 30 degrees or 40 degrees, we may not have discovered it until it was already past us. So that does suggest that there may have been many other interstellar comets and asteroids that passed through our solar system and we just didn't know it. It's because it wasn't in the right place at the right time for discovery, or it happened before our technology got advanced enough to be able to detect it. But the direction where it's coming from is where a lot of the conspiracy theories start to come out. And the most common one is connecting this to the WOW signal, which was discovered in August of 1977. The WOW signal and the comet came from roughly the same part of the sky, and in astronomy, roughly covers a lot of ground, or a lot of sky. And in this case, the WOW signal is about 9 degrees away from the comet. 9 degrees doesn't sound like a lot, but in the sky, 9 degrees is a lot. To visualize that, consider the moon. The moon at full width is only half a degree in the sky. So you need 18 full moons side by side in order to make 9 degrees, and that's a completely different part of the sky. And when you consider that this comet may have traveled for millions or billions of years, the constellations millions and billions of years ago would be completely alien to what we see today. Now let's talk about when and where to see Comet 3i Atlas from where you are. Its closest approach to Earth, or Perigee, is December 19, 2025, but we can start observing it now. Currently, it's low in the morning horizon in the constellation of Virgo, and in the next few weeks, we'll see it move towards the constellation Leo. It climbs much higher for Northern Hemisphere observers. And if you're in the Southern Hemisphere, don't worry, same story. It goes from Virgo to Leo, and you'll be able to observe it too. And because this comet is on the ecliptic, it's observable from just about anywhere on this planet, and that's pretty cool. Now, how to see and image it? This comet's estimated brightness is about magnitude 12, which is pretty dim, but if you have a large enough telescope, you should be able to visually see a fuzzy blob in space, just like you would with any comet. But it would be much easier to image, and you need at least a small telescope to do so. But the bigger your telescope, the easier time you'll have to both see the coma and maybe the faint tail that it has. Now, if you're using something like the Sea Star, the brightness of this comet is within the limits of the Sea Star, but the darker skies you have, the better chances you'll have of actually capturing it. So that's something to keep in mind. If you want to track and image this comet, you could track it manually through Stellarium, get the RA and declination coordinates of whenever you're looking at it, or if you're using a capture software like ECOS, NINA, or ASI Air, you can download the orbital information and tell your mount to go find the comet at whatever time you're looking at it. Now, when it comes to guiding, I would recommend guiding on the stars and not the comet, because we can use post-processing to fix the comet later on, and it's easier to fix one comet than 1,000 stars. And if you need help pre-processing the comet images, I have a custom serial script that you can download and install and run it, and it'll help you pre-process most of the way there, with some manual steps at the end. I have a video on that as well, so check that out when you get a chance. So my exposure tip would be to keep it under 60 seconds. I normally do 30 to 60 seconds, like both of these images of Comet Lemon and Swan. These were between 30 and 60 seconds, and I was able to get a nice comet nucleus and tail. Now, Comet 3i Atlas may take some experimenting. Maybe it's just moving way too fast and I need to start doing exposures at 15 seconds, or maybe it's moving slower from our relative position, then I can go to 2 minutes. So something to experiment with, but I'm definitely going to start between 30 and 60 seconds to see where that takes me. And when it comes to the tail, I wouldn't expect a dramatic tail like we saw with Comet Lemon or with Comet Suchinshan Atlas last year. Early images of this comet show that the tail is pretty minimal, so I am basically hoping for a blob, and honestly, I'll be happy with that. The great Michael Yeager very recently took this image of Comet 3i Atlas, which shows the tail and the anti-tail. Now keep in mind that comets, especially interstellar comets, can be highly unpredictable. Outgassing can cause sudden brightnesses or even sudden dimming of the surface, and it'll become either easier or harder to image. I would recommend looking at the COBS database to find what the latest reported brightness is of the comet and go from there. Link is in the description as well. I'll definitely be trying to image it myself, and if you try it as well and you get something, I would love to see it. Join our Discord server. The invite link is in the description below. We'd all love to have you there. There are a lot of claims online that Comet 3i Atlas is an alien spacecraft, based on things like sudden brightening, non-gravitational acceleration, and anti-tail, which by the way is really normal. And the fact that it came from the general direction of the WOW signal, which we've actually seen that 9 degrees is not close. And I want to address all of that using 2 words, Occam's razor. The simplest explanation is usually the correct one. And in this case, 3i Atlas is a comet and nothing more than a comet. We still have a lot to learn about interstellar objects. This is only the 3rd object we've discovered, so we've only been able to study it very briefly. And it's good to keep in mind that this piece of rock may have been traveling through space for millions or billions of years, so it's expected to have an unusual chemistry, unusual outgassing, and if you think about it, maybe this is the first time in its life that it has gotten this close to another star. So the outgassing it's experiencing is weird to it as well, not that it has mind. So when it comes to comets, weird is normal. And trust me, I wish it was aliens. That would make things a lot more exciting, but it's not. And playing decades of video games, we all know that you don't attack from the front, you flank from the side. So it's coming from the ecliptic. We should probably look to our 9 o'clock. If you want me to spend any time talking about more of these theories in a dedicated video, let me know which you'd like me to talk about below in the comments. To wrap things up, Comet 3i Atlas is only the 3rd interstellar object we've ever discovered, and this is the one and only chance that we'll get to observe this particular comet. So it's not a once-in-a-lifetime event, it's a once-in-a-solar-system event. So if you can get out there, image it, I'll definitely be out there any chance I get in order to get it in my camera. A huge thanks to all of my patrons on Patreon, my supporters on Buy Me a Coffee, and YouTube members for supporting me and encouraging me to make these videos. If you'd like to support me as well, check out the links in the description below and in the pinned comment. Happy comet hunting and clear skies.